that is Im is the magnitude of the current. If I am taking current as reference, then Vm will be in this direction, because in case of phasor we generally choose anti-clockwise direction. Then Vm is ahead, that is Vm in this figure. You could clearly see in the second figure, that is Im is taken as reference. Im is represented with blue line. So Im is taken as reference. So Vm is leading by 90 degree. Similarly, in the first figure, you could clearly see when Vm is taken as reference, current is lagging by 90 degree.
Yes, ma'am.
Okay. So if we want to draw the waveforms of this, then here it is. If we are taking it is equal to Im sine omega t, that is, if Im is taking the reference, see here Im is taking the reference, here Im is taking the reference. When we are drawing the waveform with the second figure, Im is having 0 degree, Im is having 0 degree. See, in the waveform with the blue graph representing it is equal to Im sine omega t. Blue graph is representing it is equal to Im sine omega t. In this case, you will be able to observe that it is starting from 0 degree. If I am saying voltage is leading, it means somewhat before it would have started. Am I correct?
Yes, yes.
Okay. Because for the inductive circuit, what I am saying, voltage is leading. That means it would have started somewhere earlier. And I am also saying voltage leads by current by a term of 90 degree. It means it would have started 90 degree before. So if it is plus 90 degree, then before 0 it is minus 90 degree, then voltage have started minus of 90 degree ahead. So this is the red graph represents that Vt is equal to Vm sine of omega t plus 90. It has started before. Okay, this is clear. So this is the waveform in which by which we could represent the phasor of the in case of inductor. Similarly, if we will find the impedance in this case, so impedance, as we know, impedance in case of inductor will be j omega L, that is omega L. J represents an angle of 90 degrees. Similarly, 1 by j, if j is in numerator, means it is representing an angle of 90 degree. If j is in denominator, it is representing an angle of minus of 90 degree. Okay, these are the concepts to be very clear to solve all the questions related to phasor. Okay, am I clear?
Yes.
Are you able to understand the class now?
Yes, ma'am.
Okay. Okay. If we're considering the phasor diagram of capacitor, see, if the three things will be clear now, then when we'll proceed to RL series or RL parallel, it will be very much similar to it. So if I could also not explain, then also you could be able to understand with the notes. I'll provide you today only. Right now only I will send you. Okay. So if you need notes or you don't need it,
Now you can send me the notes, ma'am.
what?
Now you can send me the notes.
Okay, okay. So if we'll consider phasor diagram of capacitor, so here as this is capacitor and voltage across capacitor is Vt and the current flowing through capacitor is It. In case of capacitor in time domain, It is C of d by dt of Vt. If we are considering Vt is equal to Vm sine omega t, then It is equal to C d by dt of Vt, which means C d by dt of Vm sine omega t. That is Vm sine omega t. Vm is a constant, so it will be outside. And d dt of sine omega t is omega cos omega t. So here we could see that It is equal to Vm omega c cos omega t. For drawing the phasors, both should be in same form. That is, It can be represented in the second way round, Vm omega c sine of omega t plus 90 degree, and Vt is Vt is equal to Vm sin omega t, or Vt is equal to Vm cos omega t minus of 90 degree. Vm cos omega t minus of 90 degree. So if we are observing sine terms, we could clearly see that current is leading by 90 degree with respect to voltage. If we are representing sine terms means here it is Vm sin omega t, and here it is Vm omega c sine of omega t plus 90 degree. Vm sin omega t, that means here we could see if we are considering V of t in terms of sine and I of t in terms of sine, then we could clearly observe that IT, that means current is leading by 90 degree, current is leading by 90 degree with respect to voltage. Am I clear?
Yes, ma'am.
Okay. And if there is a if some way or the round, if you are getting confused, then when we convert cos to sine, we have to add 90 degree, and when we convert sine to cos, we have to subtract 90 degree. Okay. So if we are observing cosine terms, then we will find that cosine terms means here it is Vm omega c cos omega t, and Vt is Vm cos omega t minus 90 degree. That means if we are considering cosine terms, we could clearly say that voltage is lagging by 90 degree with respect to current. In the same way round, whether you say current leads by voltage by 90 degree, or voltage lags by current by 90 degree, it is totally depend on you. Generally what we say, in case of capacitor, current is leading. In case of inductor, current is lagging. Basically what we see, by by which form what we remember, that for inductive load, current is lagging with respect to voltage, and for capacitive load, current is leading with respect to voltage. Okay, so if we are drawing the for drawing the phasor diagram, we need to be having phasor of voltage V bar and phasor of current I bar. So V bar, if we are taking V as a reference, that means we are considering the sine terms, because the graph what we will be plotting, we generally consider sine terms only. So Vm angle 0 degree, and for that case I bar will be Vm into omega c 90 degree, because it was right